Artificial intelligence, AI, has revolutionized the way we interact with technology, and at the heart of many AI advancements lies the concept of neural networks. Inspired by the biological neural networks in the human brain, artificial neural networks, ANNs, are computational models that have become fundamental to machine learning and AI. This essay explores the structure, functioning, types, applications, and future prospects of neural networks in artificial intelligence. Neural networks are a subset of machine learning algorithms designed to recognize patterns and make decisions based on data. They are composed of layers of interconnected nodes, or neurons, which work together to process input data and produce output. Each neuron receives input, processes it using a weighted sum and an activation function, and passes the result to the next layer. A typical neural network consists of three main types of layers: the input layer, which receives the initial data and passes it to the next layer; hidden layers, which perform the bulk of the computation; and the output layer, which produces the output of the network. The functioning of a neural network can be broken down into several steps: initialization, forward propagation, loss calculation, backpropagation, and iteration. There are several types of neural networks, each suited to different types of tasks. Feed-forward neural networks, convolutional neural networks, recurrent neural networks, long short-term memory networks, and generative adversarial networks. Neural networks have a wide range of applications across various fields, including computer vision, natural language processing, speech recognition, healthcare, and finance. Despite their success, neural networks face several challenges, such as data requirements, computational resources, overfitting, and interpretability. The future of neural networks in AI is promising, with ongoing research addressing current limitations and expanding their capabilities, including explainable AI, transfer learning, neuromorphic computing, and quantum neural networks. Neural networks have become a cornerstone of artificial intelligence, driving advancements in various fields and enabling machines to perform tasks that were once thought to be the exclusive domain of humans. While challenges remain, ongoing research and technological innovations continue to push the boundaries of what neural networks can achieve. As we move forward, neural networks will undoubtedly play an increasingly important role in shaping the future of AI and its applications in our daily lives. For more information, subscribe this channel.